Et alors, bonjour tout le monde.
So, good afternoon, everyone, and we are back here for this workshop. We will be starting our seventh workshop having to do with Megadata and advanced techniques, Demystified. I just want to make sure that everyone can hear me. And if not, please just lift your hand up electronically, or if you can turn on your screens, it should be okay. So, as you know, there is a simultaneous interpretation in English. If you wish, you can access this service. Just go to the bottom of your screen, click on the globe, click your preference language, and you will have the language of preference. So it's our seventh actually workshop here. We will continue actually the sixth one, which is the preceding one. For the preceding one, we had started with Bruno Agar, Professor Bruno Agard, and we had done that last week. With a type of script here, we went on the manipulation side, on textual data, and also we analyzed of some therefore today we will actually carry out an analysis, non-supervised and supervised analysis, both. I think everyone already should have received the information to what we see on the screen and to get into this file. And let me just show everyone once more in case you'll go to Colab right here, .research.google. Then you will have a Gmail account for that, open, of course, and in operation. Then you will actually go to the tab here and in research you will put 4.0 dash chair innovation space PolyMTEL, and there you'll click on that. It'll bring you to this site. I will put this in the chat just in case, so everyone could see it eventually. And here you will click on this one here, number 7, workshop, or in English. In English. So you go choose your language, and then you will get the it will be displayed. So therefore, let me actually start rapidly. It's Bruno and I that will actually do the workshop, and I will do a quick type of the preceding workshop, what we're functioning, what we were looking at. So to just have a small recall how to work it. And then the Professor Bruno Agard will talk about non-supervised methods and supervised methods. And then more attention will be put on the algorithms, of course, and on the segmentation algorithms, he says, and also for the supervised, the multi-level. It should last around 50 to 60 minutes, and then hopefully everything will go well to actually carry out this exercise. I will explain the analysis of the database, and I'll put you in a group or individual manners to carry out the part of the exercise to finalize the last 10 minutes together. So let me go back to the demystification, what we did last week. We were in preparation, he says, first of all, we are on a notebook of Jupyter, and we're looking on the Google server. So we're using cloud computing here on Google, and therefore you have to execute a code to be able to have the output on the other browser. So we will start here by executing first the preparation of the environment. We click on the first block of codes. The second will be the import modules, and then which we'll be using today. And then we will, once this has been executed and there's a spinning wheel here to the left, the environment is now ready. Then we will be able to start. Last week, we had looked at how actually do the manipulation of texts to prepare actually for analysis assisted by a computer. We also had an example here that we have on the screen, of which we have a text which has been composed with 5 sentences. We can click on the small button here on the left to actually look at this variable. We also saw that there was all different functions to segment, if you want, a text into phrases, then the tokenizing effect. And then last week also, last workshop actually, it's 2 weeks ago, we actually had a small function created to permit the kind of cleanup operations, if you wish, necessary in the text. Therefore, the cleaning up operations, he calls the gentleman, we click on the cleaning text on all the sentences which were found in the text. And therefore, the little recall here, if you wish, the 2 elements that you do recall maybe. It's really fundamental to reduce to a minimum the graphic events or occurrences. If we have a verb, for example, to eat, for example, in different manners, but is still the same semantics for this model, typical model that is, that we are using today, it's better that there are not all the major occurrences with different flexions, he calls. The verb has to be in the infinitive. So all the frequencies of would have to be regrouped in the same column of the matrix. So all this cleanup, if you wish, my objective is to have this element here, reduce the most possible the vocabulary of our text to be analyzed. There are different steps to take, of course. What we saw last week was the reduction at its roots, then morphosyntactic, which will permit us to identify all the names, adjectives, verbs, etc., which are present in the text. And with this function here, we are able then to retain the words which actually go to one of the categories of our choice. For example, here I will keep this noun, the adjectives, and the verb, and I will reduce all others to its roots. Then the results that comes up is this, so of which we have the verb, we have the morning, for example, he says, the noun, we have the verb, feel, and etc. Very well. This is the first recall, and the second was the what we see of this, what we do generally. We have to actually translate it in a mathematical object style, vectorization, he calls it. Usually we use the vectorization method like this matrix here, x equals, into parentheses, we can see the document deference, or in our example here, each line will be one sentence. One of these sentences here, each line is a sentence, each column is a word from our vocabulary. The cell here is a ponderation. The most simplest is binary, and 8 presents in the first yes or no. Is it morning? Is it present in yes or no in the first sentence, etc. And then there is a frequency ponderation, and then morning appears in the first sentence and just one time, etc. And also there's also other ponderations to be considered. For example, like I explained last time, is the TF. It's a normalization of the frequency. Therefore, we have for carry out our vectorization, we use this function here. I invite you to look at three arguments for this function here. The first one would be min_def, min_def. It's the minimal of the frequency, which will have to be actually retained from the matrix. In this case, we put here each word had to be actually held in the matrix. It has to go into this documented list. And max_df is the maximum. How many maximum documents should appear? And then, therefore, they put 10 here. The other thing which is important, the n-gram range. The n-gram range will permit you to add to the matrix the e-gram. Therefore, let me carry out a trigram, he calls. Let me just carry out this exercise. For example, this morning. So in your corpus, you have this morning many times over, several times with the perimeters and the threshold, which would go to the vectorizing parameters. If this morning respects these criteria, it will be added as a bigram in the matrix. So it has to be many more of those this morning, or either bigrams, so it could stay in the matrix. What does this permit you to do? It actually permits you to the sequence of words which are more frequent in your corpus. Sometimes it's interesting to keep those, the bigram or the trigram. It's depending of your interpretation, of course, squarely, and also learning, which will permit it to actually evaluate your learning module. So really these three here, the min_df and n-gram range. This is what we're talking about here, which will permit you to add the n-grams, bigrams, trigrams, and add to the vectorization. Now, application of the vectorization, we have the matrix of frequency with the words which were kept, if you wish, after the cleanup operations had taken hold, and this frequency shows up here. And then after with that, we have the creation of the matrix with the ponderation, TF-IDF, which is a normalized frequency. And generally today we will work with this ponderation here with the matrix and with ponderation of the TF-IDF. So let me just stop here. I'll come back to that to present the exercise. And now I will ask Professor Bruno to share his screen, and please take the floor. Very well, very well. Thank you very much. I just want to check if everything is going well. And hopefully, is it okay? Can you hear me? Well, so. It's you're hearing, you're not coming through. We do see the image clear, and of course for the interpreter, myself, Constantin, and I think maybe Alain, he can confirm this. We are not hearing it well. So very well. Inaudible. After the DVD, we are making to go on the methods of the last time, principally for 3 methods of non-supervised, and to see how to use these matrices in the 2 type of groupings of methods, and also non-supervised methods. So it is something of an introduction, if you wish, but there are many methods in CDI. Here we have the metrics of distance, normalization of data, and the segmentation of algorithms. So if we will look at the segmentation 3.0. In the segmentation, the goal of segmentation is to divide and actually put the whole ensemble of the data into a subset, which is much smaller, to actually share with certain characteristics. Among the phrases we have that might actually resemble themselves. And therefore, we have to look now to see how we could actually measure 2 texts and define the number of groups and what goes in each group. Therefore, the methods of segmentation, there's many that exist, and we will choose the one for the type of data we have and the characteristics we see in the groups. So you can go through a lot different methods, but something we will use most will be the method of the average case is very, very efficient, very, very popular also. If you look at the methods of segmentation, which will be based on distance between points, of course, this proximity is measured with metrics in distance, for example. What are these metrics in distance, for example? At the base of this, of the distance of the Euclidean, distances of Hamming, and here they are. This is a small recall, if you wish, amongst the examples of the distance. Here you have the formula, which is D parenthesis x1, x2, parenthesis equals S, sigma, if you wish, and the distance between two texts as vector points considered from one end of the vector to the other vector after we will look at the distance of these vectors. These are more logical for us to use for the text, notably which actually gives distances of Hamming, he calls it. So in this software type of situations, under the names of distances of Hamming, there's a lot of subcategories to keep in mind here. So H1, H2, H3, depends, H4. Not everything does the same thing. Two things for Hamming, how to show distancing and the coordinates which resemble or the ones that are different, of course, at the same time. So we can look at it as one that are differences, di, delta, and sigma, s. We use the same on one text that uses one word and the other one does not use the word. So we will compare the vectors and to see what will appear in the both texts. If there are no difference or similarities, you'll get a 0. But if there is, then it will give you 1 point of difference. So this is the model which is the most simplest to actually look at how many times words actually appear in a text and not in others. So as this, we will also look at different inaudible, different positives, to bring it a little forward. So notably, we'll be looking at the text. There's dozens and dozens of many words we don't use. So rather than give 1 point each time there's that doesn't use the same name, yes, it's logical, but there are so many words we don't use. So we have to look at this. So we'll say and look at one. So C01, are we using both words? It's 1 point. If both of them are not using the word cheval, which is horse, then it will give you what's our different coordinates in the sense of the one that we are using. So therefore, if you use the words which we are not using, which will not appear actually, I'm sorry, he says, so there's also an amelioration or an improvement on this matrix. In the next matrix, it's the same thing. We're looking at the different and positives, D3 here, but we'll actually divide it in the number of words that exist in the text and then in percentage of the data compared. So in the different percentage of data which exists, therefore in different percentages, the one used in the text, the words. Therefore, it's something that's very frequent, if you wish. It's these two metrics with the data given, distance, and sometimes we want to it will improve it. We will use text, improve, to compare text, actually, which will use the text and do also a resume. And for example, we will put more weight, if you wish, more value, a probative value, for this way the text will resemble. If we're to be able to see, to make the ponderation of certain data, more weight if I use the same words rather than if I don't use them. So and then we can have that method of ponderation more if I use the same words. Then the words that appear in the introduction, in the conclusion, and the ones that appear in the middle of the text. So with this, the distance and the positioning of the text and the words, sometimes we could actually bonify, ameliorate, improve, actually, augment. So these matrices here, I have shown you some. Here the matrices, 5. And there also exists other versions which are adapted for Hamming, says the gentleman, the professor. And then the DI, for example, delta 1. Why? Because your needs are unique. If you want to compare data, for example, that are with our scientific articles or articles of law or something, it will not be the same thing to be able to be used. We'll be using some other different kind of module, different ponderations, of course, and vocabulary or not. And there we will say very often to actually augment, he says, the text of which we will work. So, for example, let me give you an example at the bottom of this, and then we will use the cosine method. We will look at the angle under the two vectors. So, and then again, it's up to you to keep an eye out which context you have. We will put, will you accord more value, if you want, more probative value, more weight to that or not? So we will choose a matrix here, and that will be the distance between two texts. That's what the matrix will do. So the text is very well, but it is not enough. We have to go now to what's called to hypermetric distances between groups, between a text and a group of texts. So what I have to actually put here, which and single linkage, complete linkage, he says, an average linkage. Also the distance of gravity at the center. So in 1, it will be the single linkage that you will resemble a lot. Then you will say, no, let me put it into shelf number 2, because despite the fact in 1, it's very, very different than 1. So what is the one that resembles most? It's better to go far from the one that's different. So you have to differentiate it. And then the distance, which is the average distance, which is the average linkage. And do I put it in function, which is, or do I put it further from the object itself? So, there you have the average linkage, the distance from one to the next, and also the distance also from 1 to 1. I have to make a ponderation on one level he calls of the gravity center, the center of gravity. So if I give at what point, if I give 1 million books to each one, at what point it will actually be similar. So it will represent itself. This will be the representative, inaudible. His sound is not the best. I'm sorry, the professor. And therefore, these are the matrices we are looking at. One text resembles, the book resembles another book resembles, and we will be able to see how we will do this hypermetrics distances between groups. Therefore, after that, I will compare one book to another or to a group of books. And be careful here. It's important in the matrices of distance to normalize our data. Well, we saw the things which are based on data, and it's very important to normalize our data, he calls, quote unquote. So normalization. We have 3 texts here, which uses 100,000 the word, and then a vocabulary, and then 100,000 also mother, the one-time mother, and the completely resembling type of vocabulary from 2. I calculate the 2 vectors together to make the calculations between them, and then I have these numbers here, 100,000, and if I calculate the distances between the 2 of them, it is this, because Mama is very, very popular. It's 100,000 times that they are in accordance, and 6 times they are not in accordance. Because maybe it's not because 100 there's 100 pages that there is 100 mother, but it clearly is a very strict correlation with resemblance there, he mentions. So then there is the first word that is used, and this is the distance of the Euclidean, 0.112. These texts are very, very different. So this decimal normalization the professor is pointing to right now is normalized my data. And we have to know that the first 2 texts we use more mama than the second one, rather than to know, namely the 100,000 mark. So then there is a different way of normalizing the decimals. You'll have the XD, which is X copy mentions. For each column, bring that into your 011 here, which will have to redivide it. He goes by 100,000, which will divide it. Sorry. We will see the texts will come out as the last two ones rather than the first two ones. Then there's also a different ways if you wish to do normalization process, because our text could actually be some we use 103 says, and others we don't use. So we will look at this mini-max scalar, he calls it. What is the minimum and max of each word used? For example, in each column, we will bring it forward to 01 without having been at hand to verify how many times in packs of 10 I have. So we will see here exists a different ways to normalize. For example, he underlines the minimax scalar at this point, and in minimax, and also my older type of pack of data, which is here, which is the former one, he calls it. He will use XAM here, talk about a tool he calls to put it into scale type of tool, a scalar, if you wish, and then that will transform it. So this scalar tool, and exists also the inverse transform on the scalar. The ones of data have been normalized. So, namely to see how many were actually used the first time. So in reality. So if I normalize that before, we will find that rather than normalize on the max, on the variances, we can normalize on the variances also. So to look at certain properties which are independent of all these, actually, in the text. So it's not always true, but we will consider that the texts are independent, and we'll consider that notion. And some texts from the two ones are more. So just to actually be careful with that, and to actually look at the abstract collision vectorizing process. Am I using the word yes, no, yes, no, yes, no? These are the, and sometimes we will have that rather than normalizing, we will have the assignation or of the no, and then I will go down. It will be used very unbalanced in the text. So therefore, if this case exists, you'll have to normalize your text. Following that, after we will go now into 3.3 algorithms, which calls the draw function to plot results.
Les logarithmes dans des échelles plus proches. Alors, méthode non supervisée. On est dans la segmentation. On a parlé rapidement des métriques de distance. Faire attention que les métriques de distance, normaliser les données qui justement ne sont pas normalisées au départ. Maintenant, j'ai des outils pour mesurer la distance entre deux textes, entre un texte et un ensemble de textes. Et puis, si jamais j'ai des données débalancées, je suis capable de corriger mes données. Donc, maintenant, je suis prêt à travailler. Alors, on va regarder un petit peu maintenant comment fonctionnent les algorithmes de segmentation. Alors ici, on vous a mis un premier petit code, une première fonction qui va juste nous servir à représenter nos données de manière graphique pour voir un petit peu ce qui se passe. C'est juste une fonction graphique qui va permettre de représenter le deuxième code qui est ici. C'est pour générer des ensembles de données. D'accord, pour capable de faire tourner devant nos ordinateurs. Alors là, en fait, j'ai généré 4 ensembles de données assez proches les uns des autres, mais avec du bruit. Vous voyez, ces deux ensembles sont proches. On va voir si on est capable de les retrouver. Alors ça, on va supposer que c'est nos textes pour l'instant. On utilisera sur des vrais textes. Mais si j'ai d'autres textes qui utilisent du vocabulaire similaire, et puis on a en fait la distance de 1000 textes les uns avec les autres. Et on va regarder comment on fait dans ces choses-là. Sur l'exemple qui est ici, parce qu'on le voit bien, c'est un exemple qu'on a généré, puis après on le fera sur des ensembles de textes réels. Alors, la méthode de base en segmentation, c'est la méthode Camille. La méthode K-means, c'est un
So we're
algorithme
going to take a look at
de
the
segmentation.
k-means method. It's a
C'est-à-dire que
segmentation
sur
method.
nos ensembles de points ici, on va segmenter les données. C'est-à-dire, en fait, on va le couper
So we're going
dans
to
la
cut
méthode
it.
K-means par des droites. Donc, on va
We're going
tracer des
to cut
droites
it
dans
with
nos
straight.
ensembles de données. Par exemple, on pourrait tracer une droite ici
So I could, let's say,
pour
put a line
séparer
here
le groupe qui est là.
in order
Après, je
to
peux
split.
retracer une groupe
And
ici
then I
pour
can
séparer le groupe qui est ici.
have
Et
another line
petit à
here to
petit,
split.
on
And
va
little by little,
segmenter,
I'm
tracer
going
des
to
segments de droite pour isoler
do
nos groupes.
some segmentation in order to isolate the
Alors,
clusters.
la méthode de segmentation,
So this segmentation method,
où on coupe avec les droites, mais un texte, il est
well,
d'un côté de la
one
droite ou de l'autre.
text
Ça veut dire qu'un texte,
is it
il
on
va être
one side of the line or the other?
dans un groupe ou dans un autre. On va
So
voir un tout
it
petit peu
may
plus
be
loin
in
tout
one
à l'heure
group
des
or
méthodes
another.
hiérarchiques.
So
Ou un
there's a
groupe peut être,
hierarchical
par exemple,
method.
c'est un roman policier
So imagine
du Moyen-Âge. Donc, c'est pour avoir une étagère Moyen-Âge, et dans l'étagère Moyen-Âge, il peut y avoir un sous-groupe policier, puis un truc guerre.
so
et puis
imagine there's a
religion,
bookshelf,
et
and in the bookshelf I have different
dans la
categories
méthode
of
Camille,
text.
je suis dans une étagère ou dans l'autre, que dans les méthodes hiérarchiques, il
So
peut
in
y
a
avoir
hierarchical
des groupes dans
method,
les groupes.
you have groups
Alors,
within
là,
groups.
on commence par la méthode de segmentation.
So we're going to start with the segmentation method.
Que fait la méthode Camille? Ben justement, elle va essayer de trouver les espaces, enfin, les endroits
So we're
pour
going
couper
to
notre texte, de
find some
manière à ce que
spaces
tous les
to
textes
cut our
de
text in order
chaque
to make
côté
sure
de la droite, de l'endroit où on a coupé,
that
soient le plus similaires les uns
we
avec les
can
autres.
find
Similaires les uns
the
avec
most
les autres,
similar
dans le sens de
segments
Camille,
from one to the
c'est qu'on va
other.
calculer la distance de
So
tous
we're
les
going
textes
to
à tous les,
calculate the
de tous les textes
distance
à tous les textes dans un groupe,
of
donc
all the
la
texts
distance de
within
tout
the group,
l'argent de chaque groupe. On va regarder
and we're going
si
to take a look
je minimise de chaque côté
I
la
have to
distance
minimize it
au
on
livre
each side.
moyen du groupe. Donc, c'est comme si je disais que
So it's as if I was
je pense que
saying,
si je coupe ici,
and
je
I
vais
think that
séparer
if
les
I
deux
cut
groupes parce qu'ici,
here and I split both
je suis
groups,
capable de minimiser la distance
here
à
I
ce
will be able
groupe
to
moyen qui
minimize the
serait
distance
représenté par la flèche ici,
represented by
minimiser
the
par
segment
rapport
here.
à un groupe moyen de l'autre côté. Donc, quand je fais la segmentation,
So when I'm doing
le
the
résultat
segmentation
qu'il
here,
va y avoir, c'est que pour chacun des textes, on va
for
lui dire,
every
t'es
one
dans
of
le
the
groupe
texts,
1, t'es dans le groupe 2, t'es dans
you
le
have
groupe 3,
one
t'es dans
that
le
is
groupe
group
1, t'es dans le
1,
groupe 3,
one,
t'es dans le
2,
groupe 2.
one, 3,
Donc,
and they're segmented like that.
on va rajouter une étiquette qui va
Then
dire
we're going
pour
to
chaque
add a
texte
tag
dans
for
quel
every
groupe
text.
je t'ai mis. Et ben, en fait, on va rajouter une vecteur de sortie
So we're
qui va
going
dire,
to add
pour chaque
a
texte,
next
tu es dans
vector,
le groupe 1, 2, 3,
and
4,
then
5,
we're
6,
going to
7.
say for each text, you're in the
Avec
group
la
1, 2,
méthode
3, 4.
Camille, K définit le nombre de groupes.
So
C'est nous,
with the
au
method K,
début,
we
on
can
va
define
dire,
the
ben
number of
moi,
groups.
cet ensemble de textes,
So this
je veux le
ensemble of
partager
text,
en
I
8
want to
groupes,
share
3
it
groupes,
in
7 groupes,
8
22
groups,
groupes.
8 groups, 22
Et
groups.
la méthode Camille va mettre chacun des
And
livres dans
every group
dans les
will
groupes qu'on a
split
définis. Si on
it.
lui donne 22 groupes,
Let's
après
say in
22
our
groupes, il va
example,
mettre
every
chaque
book in
livre
each
un
every
numéro
category, and so
de 1
every
à
book would have
22.
a number.
Et
Let's say 1 to
Peter de
22.
0 à 21.
So
Alors, la méthode Camille
now with
existe
the
déjà dans Python.
k-means
Donc,
already
on va
exists in
charger la
Python,
méthode Camille
so
qui est
we're
dans la
going to
bibliothèque
change
d'un
the
petit kit.
we're going to import the
Très facile à
k-means
utiliser.
method.
On va dire, ben, par rapport à mon
So we're
ensemble
going
de
to say
données,
in order
l'ensemble de données qu'on a
for
généré
all the data that I have
aujourd'hui,
here in the
je vais dire, ben,
variable
sur l'ensemble de données X,
and the x,
fais-moi 4 groupes
make
avec la
4
méthode Camille.
clusters with the k-mean method.
Et le résultat, ben, donc là, il va apprendre un modèle de comment faire un groupe. Et puis, je lui dis, ben, ce modèle, tu l'appliques aux données que tu as utilisées. Puis,
So this model that
mets
is
dans
applied to
la
all the data,
variable Y chapeau,
it
ou
is
pas
in the
Y
variable
chapeau, dans la variable Y,
and in
cette
the
variable
y
Y,
variable.
ben, donne-moi
Wow.
dans quels éléments sont les
Tell me
groupes. Alors, il va
in
faire les
which
groupes.
elements do we find
Et
the
puis,
groups.
chaque groupe,
So
avec
every
la fonction draw
cluster
qu'on a fait tout à
here
l'heure, va être représenté d'une
will be
couleur particulière.
represented
Donc là,
in
je
a
dis,
different color.
fais 4 groupes. Alors, il a trouvé, il a fabriqué les 4 groupes
So we're
représentant
going to
chaque
have
groupe en une couleur différente.
every group will have.
Comment est-ce que fonctionne cette méthode? Alors, la méthode Camille, c'est une méthode itérative qui veut dire qu'on fait un calcul et puis on avance et on reboucle plein de fois jusqu'à ce qu'on soit capable de stabiliser ou d'avoir une solution qui nous plaît. Comment il fonctionne? Alors, au début, ben, on va lui dire combien de groupes on veut. On lui dit, je veux 4 groupes. Alors, la méthode va choisir 4 livres au hasard pour dire, ben, ces livres vont être représentants de mes 4 étagères. Et après, tous les autres livres, on va regarder ben, à quel point chacun des livres est ressemblant aux 4 livres que j'ai décidés. Alors, je vais faire un groupe pour le premier livre, un groupe pour le deuxième, un groupe pour le troisième, un groupe pour le quatrième. Et après, dans chacun de ces groupes-là, Là, j'ai fait les groupes pour chacun des livres. Pour chacun de ces groupes, on va regarder, par rapport au premier livre, j'ai fait un groupe 1. Mais est-ce que le livre que j'ai choisi en premier est vraiment un bon représentant du groupe? En général, non. Donc, on va dire, OK, bon, pour ce groupe 1, j'ai mis 30 livres dedans. Finalement, ce n'est pas le premier le plus représentatif du groupe, c'est le 8e. On va dire, OK, donc, le nouveau livre, le 8e livre, va devenir le livre représentant, enfin, on va prendre un livre moyen qui va être représentant du groupe. Ce que je veux dire pendant le livre représentatif, c'est une autre méthode camédoïde qui ressemble beaucoup. Donc, je choisis 4 livres. Après, je prends les 996 autres livres. Pour chaque livre, je dis, tu ressembles beaucoup au livre 1, ou au 2, ou au 3, ou au 4. Je fais des tas. Et après, je vais calculer un livre moyen. Et on va dire, OK, est-ce que le livre que je vais choisir au début ressemble au livre moyen? Si ce n'est pas le même livre, on recommence le calcul. On dit, OK, maintenant, on va refaire une itération avec le livre moyen et on va répéter. Donc, je choisis des représentants, j'affecte les livres dans les groupes, je recalcule le centre des groupes et je recommence. Alors, on va voir, par exemple, ici sur un petit exemple. Alors, on a choisi 4 points au hasard pour faire nos itérations. Alors, à la première boucle, je ne sais pas, il avait dû choisir un livre rouge par ici, un livre bleu quelque part, un livre orange, un livre vert. Il a fait des premiers groupes. Puis, est-ce que le point le livre que j'ai choisi à la première itération représente bien le groupe vert, représente bien le groupe rouge, etc. On change de représentant, on refait une itération. Alors, si vous voyez là, il y a par exemple, le livre ici, il y a des livres qui ont changé de groupe à la première itération. Comme je change de représentant, ce livre-là, qui avant était proche de l'ensemble vert, finalement, est plus proche du groupe rouge. Et on refait une itération, puis on va voir que les groupes bougent petit à petit. Donc, on a un autre point qui est réaffecté, et puis petit à petit, on voit que ça se stabilise, ça va converger vers des groupes différents de ce que j'avais au début. Donc, je choisis des représentants. Ces représentants sont au fur et à mesure, et chaque groupe est représenté par un livre moyen, qui n'existe pas, mais c'est le livre qui voici en moyenne ce qu'il y a dans chacune des étagères. Alors, cette méthode, faire attention, c'est qu'elle est très sensible aux points de départ. Donc, en fonction des points de départ qu'on choisit, alors là, j'ai fait changer les points de départ de l'initialisation et j'ai fait avancer l'algorithme plusieurs fois. Donc, oups. Donc, qu'est-ce que j'ai fait cette chose-là?
Okay, sorry. And she just wants to look at that, why he did that, says the professor, looking at the range and random state clusters right now. I had to modify this code here. We have the random here. We have to put RS here for the random, then click on the little spinner and then get back into the random. Just waiting here. Excuse me, says it's something that I must have done. I wanted to show you the starting point. We don't always have the same result. We have to be careful here in the manner that we actually choose our points, our starting points. So we have to be careful. Now, if we go to the conclusions here, be careful and sensitize yourself to the initial choice that represents the algorithm, and the results will actually depend on these following things. For example, if I had taken 4,000 medevals, he calls them, then on those types of shelving or types of levels, he calls them, if at the beginning, if I actually more diversified at the beginning, then I would have to go towards those spaces which are more diversified. So be careful with the sensitivity of your choice, your initial choice, which represents the algorithm of the Optimum K-cal, he calls it. And therefore, we don't always know what the initialization is or impact of the results for the k-means. Therefore, the quality of partitioning, he calls it, we will actually do different type of several draws, not different, several draws. And we have to choose actually judiciously in a careful manner the initialization of the functions and their knowledge of the problem. We have to apply the means with different points of the depart and the start and the also keep the maybe the best result. Or maybe he says I'll use the point of initialization, and I really have to be careful choosing those starting points, he says initially. And I say judiciously, very carefully, really canvassed out, because the types of text which I have to put into triage to actually choose from the different texts and different texts, which will permit us to actually have groups which actually go together. When I don't know, there are different types of draws I can make on that to apply the k-means and also to apply the best specific methods. So now we will go to the conclusion.
De manière automatique, en fait, par Python. On peut
So we can leave it the possibility to choose our starting point. So we can have a cycle first, and then we can have it choose books randomly, and then we can find a book. It's as if we're just, so we can choose the books without really knowing anything about them. So, Kenny, we're going to define the number of groups. So we have the k-means, we have the data. So here earlier I had 4 clusters, and then here I say 1 group. So if I put 2, then I'll have 2 groups. Then 3, 4, 4, 5. He'll give me 5. And if I ask whatever, he'll do whatever. So what we have to be careful about with the k-means, well, we choose a starting point, but you all have also to know how many groups you should choose. So this is really good to find groups, as long as you know from the very beginning how many groups you're looking for. So we're going to see here, we're going to learn soon how to choose the right number of groups. So here we see that in my case here, I like this one better than this one. I'd rather have 4 than 3, because for instance here I see the orange group. The orange group still has some books. So there still can be very different books. Here there's less diversity, and then there's less diversity in the green cluster. So here we have a matrix to see how many there should be in a group. And then we're going to take a look at what are the variability into one group. And then we're going to measure the distance between a group. For instance, we're going to take a look at the distance between, and are the clusters rather, separated from one another. So here we have the silhouette method. The silhouette method calculates the dispersion within a group. So with the k-means method, when we split them, so how do you choose the number of clusters? So the advantage here is that this method is quite quick. So we're going to calculate the number of groups, 3 groups, 5 groups, 6, 7, 8, 9, 10. And then I'm going to say 2. There's no point in putting 1. And then we're going to put until 30. So we're going here to calculate the distance between one another. So we're going to have a better cutting. So for Python here, it finds that 2 were here, and then the best number is 4. then he says 3 is not that bad, but 5, not that bad. But as the more I put them, the more it's interesting. So according to results that I have here, 4 is good. So it's not very hard. So I'm going to reapply the previous method, and I'm going to cut it in 4 segments. I didn't know how many groups that I wanted. So I'm going to put 2 until the number that I need. And we're going to take the maximum at the matrix. So sometimes you may have different maximums. Perhaps it could be 6, 7, 8. And it's going to make some propositions of several kinds of maximum that we could have. So do I want to put 4, 5, 6 segments? It's up to me. But for instance, between this one and this one here, it's so similar. So there's no point in putting 8 or 9 segments. This will provide me the same level of information. So if we take a look at our text from earlier, so we're going to display the text here. We calculate the TF IDF matrix. If I'm using the k-means method, I have 2 groups, and what will it say? It finds one group with the first one, second, and last one. So this sentence here, and this sentence here are similar. And then another group, it says that these 2 strings here are similar. So I'm saying how many texts that I want. So these 2 are looking alike, and this one as well. So if I want to establish a hierarchy, if I want to organize my books in a thematic way, well, there are some hierarchical methods, and they are based on the distance between the texts with one another. Rather than here, we're going to calculate the distance between every element. So we're going to take a look at our first with our 1,000 texts, and we're going to calculate the distance between one another. So I'm going to compare the first one to the 1,000, the second to the 1,000, the third one to the 1,000, and etc. So I'm going to make 1,000 calculations. And once I've done that, I found that 2 texts are similar. These 2, I'm going to join them together. So the other 998 ones, they're going to be split in 2. So the distance will be smaller. So we're going to put a third one with this, and then perhaps there'll be 2 other books that will be similar. And then I'm going to recalculate the distance between the 997 others. So I'm going to make a third one. And I'm going to calculate 996, etc. I'm going to do this all over again. So I'm going to do many calculations. I will say these 2 are similar, and I'm going to recalculate every other book. So the method is much longer. So if I have for instance, these 2 clusters are similar. I have this cluster with 5 books here, are similar to the other cluster with other 5 books. So I'm going to regroup them with the same number of data here. Here, this is represented in red. And then we can see here, we can figure this as one big cluster. These 2, and then there's one group here, second, and I have the 2 other ones that are closed, and I have a third one here. I have this set, And if I want 4 groups, I just have to split it here, this split here, and this one, and this one. If I want to cut a bit lower, then I would have 5 groups. So I can just cut with an imaginary line, and as I go down, then I would say, okay, take this one and put it on this one. If you keep it in, cut it in 3, then you would cut it at a different place. If you want to cut in 4, then you would split every color differently. So you can do this all over again. And then you can establish a hierarchy according to what you want to cut. And then inside this group, I can have 2 subgroups. So inside the red one, imagine, so if I want inside this block, I can establish more smaller groups. So these are the way hierarchical methods work. We have a good segmentation. We want to know how many groups we want to have. We can choose in the very beginning, and then we can have the right value. With the hierarchical method, it is the result of the method. So the hierarchical method, it is better because we have some solutions, 2, 3, 4, 5. So you can see here that it might take a bit more time. If we have 1 million texts to classify, well, 1 million times, well, it's not that exceptional. But then you have to calculate a million by a million in a matrix. So, but then you would have to do 1 million minus 1, 2, 3, 4, 5, etc. So the time to calculate this becomes quite large. So then you can use this method. So if so you have the text 2 and 3 that are together, and then you have the first 2, 3, 4 here. And you have the first and the last one, they're similar. I'm not going to explain this method though. But this DB scan can say these texts are different than the others, but they're just noise. We have to be careful. These are the group, and the ones in blue, they're quite different. They're different than the other ones. I don't really know where to put them. So we can close the group here. In every group, we can calculate how scattered it is. What we can do, and we can say in every group how many other books there are. If I have 1,000 books, if I have an ensemble with how many books and those books, so we can see how they can be split up. And we can see how are those groups made. So for instance, the first group, it's using these terms rather than this one, and we really like number 3. And then we have here the second box. In the first one, we use more the first one. And then in the third one, the group number 2, we use this terminology more. So we can actually see if there are books that shouldn't be in one and should be in another group. I know that I'm going a bit fast. Here I have a supervised method. So the books didn't have any classification. So these books are similar. So what we're trying to do here is to find a way to put the books in groups that I've done before. Here, for instance, this book is a history book. This book is a biology book. So there are already some books that were classified, And then there's a new one. And this one, I want to put this into the same criteria as before. So where am I going to, for instance, there is someone who comes and brings a bunch of new books. You don't want to start all over again. So you want to reclassify the books. New books, you want to reclassify them as the old ones. So if you don't know how to put the books in one place or another, so you must have a greater sample in order to know how to classify the new books. So I added here a bit more text. I've added 2 lines. I've seen some similarities. You see here, you have here in the street, in the street, in the street. You can see that it's similar. And here you have, okay, you have a dog here. And one dog here is on the street. So, is this book with Arthur? Will the book be put with Arthur, or will we make the choice to put with the dog? So, as usual, we have I'm going to split them in a sentence. I'm going to clean them. I have the name, the noun, adjectives. We're going to calculate the matrix. And then we're going to take into this example. And I'm going to take only the numbers that are inside the matrix. So I have each of the text here. So how can I classify the books? In order to do that, books must already have been classified. So I have to learn how it was done before. In the example, I have the segments 1 and 2. These 2 ones are into the historical books because I have the word Arthur. And then I have the other 3. They were put in another theme. So these, the number 1 are in the historical books, and the 3 other books are in some other theme. So the 3rd book, I don't know how to classify it yet. So this is, so I have the number 5, and then this is where I should put it. And we'll see if we can learn with our neural network.
To do that with this method, we took the we don't have maybe time to explain all of this, but here I took the method to classify the MLP classifier, the different we go there before in the learning manual. And then we have this data here, an ensemble of text. I take my number 1 classifier, he calls it. It goes to the 4th cell. And this is what we have. We have the valid CLF predict, and to use it to how to place it, and the new book which group I will put it in. So I have here the train, which is already there. It says, what does the model that I'm using, what does it predict? He says, what is if my model really was well applied, then the new book, he says, where would you put it? So then you could, it will be able to measure it, meaning the learn metrics, and to see at what point, the error or accuracy is if it's well arranged. So It's perfectly taken. We see here 100%. And then in shelf number 2, what he calls it, we are able to go see if there are any errors, or is it from shelf 1 that I put in shelf 2, or if I put from shelf 2 to shelf 1. So I can look at these and look if there are any confusion matrices, accuracy predictions, he calls. So it's not serious if I put into the adult section, he says, but if I put an adult book in the children's section. So it's not serious. So I accept it, but I do not accept, however, that it's not in the other order, if I think I'm finished from my side for the explanations on the methods. And I'm not sure if I was clear or not, but if there are any other questions, of course. And now Davide will take over to put into place what we have read on the examples. Thank you very much, Bruno. It was an excellent presentation, very rich at that. And then a lot of data here, and it takes some time to, of course, look canvas out. I will do the following thing now. Maybe it's more useful to go through the exercise together, and then to recuperate and have questions if you would have any. So maybe instead of putting a group and to work between groups, I will carry out the exercise with you, all of you, and then if there are any questions, you are more than welcome. Before starting, do we have any questions for Professor Bruno in the room? No? Maybe telework. There was one question that was actually asked for, but we can actually, someone had asked, I will read the question. Is the algorithm, does it work with all the languages? For example, the k-means algorithm, or are there limits to the analysis text? Actually, it works with an interior type of matrix, but it does work with all the languages. After we have actually what we saw last week, that would be to transform the text into a matrix, something we saw last week in terms of a language problem. But then it's a question that we had last week for the transfer of matrix. And there are German, for example, that there may be a little more complicated. However, notably, the post time. We're not really able to do it at this juncture here for certain languages, and we are working on it, of course. And then in terms of German, for example, he mentions the second time in that language. So there's a lot of some research to do then. Arab, for Chinese, like in any case, there's still a lot of research to be done. And therefore, listen, I will, if there are any questions right now, you can drop them in the chat box. Let me carry out the exercise with you now. This exercise here, it's actually the goal of this exercise to fill out portions or codes which are empty. And generally, these portions of the codes are often a copy-paste that you have to do with a code that was actually presented beforehand. Therefore, the goal of this exercise and this workshop is to show you how to do a codified line, but even if to put together codes, there is a type of learning curve, if you wish. That's it. We cannot, not to be too afraid of that. This was the goal of the workshop, to actually introduce you the methods, but certainly the goal of the exercise is to talk about this codes. Let me click on this button here, the spinning little wheel to your left of your screen. what we do? So we do it on a corpus data, which is very well used in a type of automatic treatment for pedagogical reasons, for actually to develop new algorithms, if you wish, or even other things. For example, this is a data set which is actually contains 20,000 documents in segments, or are segmented into 20 thematic different themes, if you wish. So this is a corpus of which the documents exist, which are classified in a type of shelf, type of set of shelving system. So therefore, we will now use this corpus here, given the fact that it has we did not optimize the codes really quickly. We will just now take we'll select about 3,000 documents segmented into 3 different groups. We will do this now. The groups are the following. We have the autos speak about hockey, and also that speaks about medicine or medical questions. So these 3 groups here are identified with 7 with a label, a target or a value, if you wish, with 7 value tickets for automobiles, 10 for hockey, and 13 for medicine or medical questions. Now, these are all the tickets which contains in this corpus, the 20 news group. We recuperated these groups here and 3,000 documents which are classified with these groups here. So in total, we have generated a data frame, if you wish. It's a type of Excel type of sheet, if you wish. This data frame in DF shape. It has 2,979 lines in 2 columns. So the columns are the text, the documents, and the targets. That is to say, these 10 or 13, 7, 10, or 13. A text here in DF actually resembles something like this. It's relatively useful as a corpus. Therefore, after that, the goal here, and I will do it here, to begin also to fill in the codes which are empty. The second is to change we'll not do it together, to change the parameters, and I will leave that for a little later down the line, and to pre-process for experimentation of the impacts, change the parameters in certain functions. I will actually propose something here. I put forward, and change the parameters and see what is the impact, if you want, if any, on the results of the algorithms themselves. Therefore, for today, we will actually go to this first portion of the exercise. The second will change the parameters. You can do it. You're free to do it or not do it. And today or Saturday by grabbing a coffee. So a very good coffee, actually, while you're doing these. And therefore, we'll go to the construction of certain functions, which will serve us later on. To actually do the graphics or to give results in a more simplified manner.
Alors, voici la première vide que nous avons. Le vide est ici. Donc,
here it is here.
Donc, c'est un vide de l'argument list post to keep qui fait partie de la fonction cleaning text.
It's a cleaning text we go.
Qu'est-ce qu'il faut faire? Il faut essentiellement ajouter la liste.
You have to add the post tag list to selectionize of the automated service. For the goal of this exercise, I will choose the name.
Le post tag pour les noms est noun. Je monte un peu en avant.
So I'm going up here. So if you know, you have here the name, noun. So you could put, this is what I could ask you if you want to add other, here they are. So you can put an adjective, or you can put a verb. So we're going to clean the text. It'll take 1 minute. I'm going to continue with the explanation of the code. So we have here another gap. You can see here, the gap is here. So we have to fill the argument mean def with the function count vectorizer. So we can generate the matrix, we can execute the vectorization operation. It takes a few parameters to filter. So as I said in the beginning, and we can see the frequency here. So MinDef is, we see what are the numbers that we have to retain according to their frequency. So my suggestion, I'll put 15. What does it mean? It means that we're going to take the words that appear at least in 15 documents. So the maximum is 1200. So if there are some words that appear in 1200 times, so this word will be excluded from the matrix because this is a word that is way too frequent. This is something that is always part of the objective that I stated in the beginning. We want to reduce the number of words with the most discriminating words. So here we got 30,000 documents. It could have been higher. It doesn't matter. So here we're going to take. So we have here. We have the block, the portion. We generate our matrix. We see F and F. So at the very end, we have 2,979 79 documents, and then 2,988 different words.
That is the matrix of which we will work with. Therefore, so Bruno, we put here, we saw the clustering. It's actually sensitive to parameters K and parameters which permits us to actually to determine how many clusters we want. Excuse me. And like Bruno was saying before, we don't know how many to have. It's good to have actually the clusters, and therefore we could use a matrix like the silhouette to evaluate the best partition possible of this. In this code of blocks here, block codes, which he calls them, these are two empty ones right here, the min and the max, number 2 and 3. The minimum which is required and the maximums of cases required. You have to evaluate here which partition you have to make, Bruno, beforehand, actually from 2, because he was actually doing the partition of 2, a maximum of 30. He did that, Bruno, before, the professor. And I will put 10 here. Therefore, we evaluate a variable of the partition of 2 clusters to 3 clusters to n clusters until. Then he presses on the little round spinner, and then we have to assign here the k-means, right under to assign a cluster to each example. K-means will come up here on the screen again to the 3.31 k-means, go to the other k-means, so do the model here of the k-means number 3, and a little spin again. Let me just come back and go to the module, and here he will look at executing the cluster with case, and the gentleman just look, and he will refresh the spinner wheel, and 10, but it could be 5 also. The question was inaudible from the floor. And then we're looking for the silhouette. While you are looking for that, the code. I put into the chat an address to get to recuperate all the languages from the library sections, so which ones work, which ones don't work with the languages. So there is a link there. Thank you for that information, and those gleanings are very helpful. 2 to 10 now, you'll find out. Here is our silhouette, which is traced on the chart. We see that we have something it fits well. 3,000 documents are minimized in 3 classifications. But we also see the partition here, which is when a little better. He says, will not enter into dimensional issues or problems, or the relation of these matrices are generally the risk silhouette, which comes up because each partition is better than the other. So already here, we see here are 3 here, which are very high. We have others, and which could be also correct. And here, the only thing I want to see here, I don't want to go into 1, 2, 3 or estimations. It's a matrix with 2,988 dimensions. So generally, it's the math. Once we have so many dimensions, it starts to get complicated. But in multi-dimensional space, the characteristics are actually complicated, he says. But, however, it's still doable. And then once we do a text analysis, a genetic analysis also, we suffer from this problem here, this multi-spatial dimensions. We see here the silhouettes, which give us 3. It's very well. It gives it to us right here, where the little arrow is going. And if there are anything much higher, means the semantics or the text, is very, very complicated. And this group here, which are not, however, reviewed by the data sets, and therefore, if we had the text, it will be okay with a silhouette 8, for example. So the text actually would be complicated. Here, we will fill out another empty section. The n clusters from the k-means function, another algorithm from k-means clusters, perimeter k, n clusters, the name of the cluster. Here, I suggest to put 3, because we know we have 3 groups, and therefore we have a silhouette here. We have a model with 3 clusters, which are devised from this manner here. 0, there is 738. Cluster 2, there are 1,359. Cluster 1, there are 882. Therefore, now we go to TF-LDF. We can look at what it gives actually for with the graphic, what this partition gives us, and the spinning little spinner is right beside the TF-LDF, just to give you where it is on the screen. And it's very complicated. First of all, you have to do a dimensional type of reduction, he calls. And therefore, we have 2,900 and change to put a graph in 2 dimensions. And you have to use a type of graph, which is a type of reduction type of. Here, the algorithms are showing up. And this class 2, which has been spread out everywhere, class 0, which the method or the multidimensional, it's very, very far from the other ones, which are scattered, he says, or dissipated in this manner. And the red goes into, which are much further for the dimensions. We cannot see the difference because of dimensional issues here. And the pink, the purple part is to your left, sorry. Now, to be well, we will actually verify if it falls well. First of all, let us verify the intercluster. If I look at the words which are more important words for each cluster, well, 0 has these words here: car, engine, oil, dealer, price, etc. Second cluster has game, team, hockey, doctor, people, food, bank, and distribution, disease. We see here that the groups are starting to trace themselves. We're starting to get tracing. Now we look at auto, hockey, and medical. Inaudible. Question, inaudible. in the list, so the most frequent are in the first one, not really the most frequent, but the ones that have the highest TF-DIF, like we mentioned, these are the most frequent in the documents. So, therefore, I will evaluate this partition here with this. I will leave you. You will read it, how to do that. I have 80.87% of accuracy. Then 87% of the accuracy, non-supervised, by looking at the distance between documents, it was at 87 to regroup the documents in the good category, which is not a bad number at all. So looking at the distance between the words, and doesn't look at any other things, of course. Now, the supervised method, it'll be more performant, says the professor. And I will do the operations that I did before. I do a train test and a type of learning curve test, he calls it. Here you have to fill in. You will do it on your own. You have to put the corpus, the matrix of learning for the train, which we call it, and also the label, which is actually correlated to the matrix of the learning matrix. So we give 2,600 documents, and we see for each document, what is the label? What is the classification? And there it goes. So therefore, we have so takes it from there, and we'll go to the perception multi-levels, if you wish, and then look at the code. He's looking at those layers, the multi-layers or the multi-stratum, he calls. And there we go. And then we're going into the classification documents, which had not had been suggested, the auto, hockey, and medical. So then you will follow is just in the middle of the screen, the predict X train for validation and X test for predictions, and this the evaluation. It's in, so the X is in capital letters, the Y not. It is able, then it shows to classify with less than 1% margin of error a document of these three subjects here, which is autos, hockey, and medical. Therefore, there I will finish this exercise with this. And are there any questions? No questions. Do you have any questions? Please go ahead. I do suggest to do this Saturday morning with grab a coffee and do this on Saturday, on a nice Saturday morning, says a gentleman. Catherine, did you get the same results? Were you successful in getting the same results? Inaudible from the floor.
Ouais, exact. Oui, exact.
C'est exact. X test. Maybe if it gives an error, maybe there's something you did not click. It's possible this one here. It's this one. Probably you did not execute. So if there's no questions, we will see each other in 2 weeks on the authorization of, and always at 12 o'clock, high noon. Thank you, everyone. We will see you soon. Thank you. Thank you to the interpreters, and have a good day.